attention, please. Your attention, please. This is not a drill.
Okay, I know that was maybe just like a tad dramatic, but please just indulge me for a second because I have been waiting a long time to say this, and the rest of this video is going to be about mostly kind of boring stuff like directory structure and slicer settings. So I gotta get my kicks while I can. One sec. I open sourced a knitting machine. If this is your first introduction to the project, first of all, hi, welcome. You should know that this video is part of a whole series, and there's actually quite a lot of background information in those other episodes that I won't be fully reiterating here. I strongly recommend that you go check out those other videos before committing to printing, building, or using the machine. And I especially encourage you to do so before making any suggestions or if this video leaves you with unanswered questions. The context you need might already be addressed in one of those other places. But with all that said, here's a little recap of things that I especially want you to know. This is a personal project, not a product. It's only been tested in a pretty limited set of circumstances so far, and it's probably got a few bugs and imperfections. So please be patient and polite if you find something that doesn't quite work as you expected. This machine is manually operated. It doesn't have any motors or electronics, and it doesn't autonomously knit for you. If you've never machine knit before, understand that you're signing up to learn a whole new skilled craft. Full automation is not really a long-term priority for me, so the design so far is not really optimized to lead in that direction. But if that is something that's important to you, I did mention a few other interesting projects along those lines over in my research and literature review video. The current design is fairly basic. It definitely doesn't have some of the bells and whistles that you might find on other commercially produced knitting machines. I have lots of plans for additional features and improvements that I hope to add over time, but I can't guarantee if or when those will be ready. For more context on that, check out my video about the design process. Speaking of the design, and this is also covered in a truly nerdtastic amount of detail over there, the system revolves around the dimensions of a specific knitting machine needle. Unfortunately, you can't really substitute a different model of needle unless you are prepared to completely overhaul the cam layout and then spend quite a lot of time testing it. It's not as straightforward as just plugging in a few new measurements. This is a mechanism made of tiny melted plastic noodles, which was designed by an actual clown. It's intended for individual creative use and is probably not robust or reliable enough for commercial production knitting, even at a small scale. If knitting for profit is part of your livelihood or you're hoping for it to be, please don't rely on this project for that. It just wasn't designed or tested with that type of use in mind. Similarly, the machine components themselves were not designed to be mass manufactured for sale, so, I don't really recommend that either. No, I didn't invent knitting machines. They've been around for hundreds of years. I just designed this one. The knitting mechanism is based on the same underlying principles as other domestic knitting machines, but a few notable differences between it and other machines are everything except the needles and screws can be 3D printed. Certain features are customizable, so you're not limited to, for example, a particular gauge or number of needles. And if you're feeling adventurous, you can remix and tinker and build new features on top of what's already here. So in the video description, you'll find at least a couple of different places where you can pick up the STL files for this project. If you just want to download the default models and start printing, any one of those places should send you off in the right direction. However, if you're planning to do any customization or if you want to have a peek at the code, you'll specifically want to head over to the GitHub repository. In that repository, you'll find a few different types of file. In the STL directory, you can find pre-compiled models of parts with the default settings, ready to be sliced for 3D printing. If you know you're not interested in customizing or tinkering and you just want to start printing parts, grab this folder and feel free to skip to the next section. The SCAD directory contains the modeling code, which can be viewed and edited and rendered in OpenSCAD. This code is divided into parts files, each of which can render and export a single component, or in some cases, pairs of related components, assemblies, which can help visualize how all the components should fit together, and modules. This is utility code and parameters which are shared across multiple parts and assemblies. If you want or need to make changes, the key parameters are mostly in the params file. Values that are open to tweaking are named in camel case. For example, you may want to change the number of needles in a bed, set a custom spacing between needles, adjust the size of screw holes, or fine-tune your clearances. Keep in mind that if you do change any of those values, you will also need to open up the individual files for any of the affected parts to view and export your updated models after saving your changes. The STL files do not automatically update when the SCAD models are changed. You should avoid changing values marked as constants. So those are going to be in all caps or screaming snake case. These are carefully calibrated to the needle dimensions and should generally not be changed without also adjusting the cam design and the associated SVG assets to compensate. I do not really recommend that you make any changes to the cam layout unless you are very familiar with the project and committed to doing probably quite a lot of testing. The SVG directory contains 2D shape assets exported from the technical drawings, which are then imported by the SCAD files and extruded into 3D parts like the cams. The code relies on these assets, but you shouldn't really need to access or modify these files directly. If you do need to make any changes to those shapes, you're going to want to head over to the Technical Sketches folder. This directory contains design drawings, which can be opened in Adobe Illustrator and possibly some other vector drawing applications as well. These can be used to inspect the cam layout, obtain precise measurements and coordinates, and export SVG assets. So these are provided for your reference, but I actually do not really recommend that you make changes to the cam layout unless you're already very familiar with the project and, like I said, committed to doing a lot of testing. If you do make any changes here, you'll need to export the SVGs and update associated parameters manually. Nothing will update automatically from here. And of course, you'll also find a README document, which might at this point look suspiciously familiar, and a license file. I recommend sourcing all your hardware before you start printing any parts, because if it turns out that you need to substitute, say, a different size screw, for example, it's better to find that out before you've spent 12 hours printing the wrong size holes. However, another big important reminder here, the knitting machine needles are not interchangeable, and you won't be able to make substitutions by just changing the needle measurement parameters like you can with some of the other parts. When sourcing your needles, please look for those intended to work with brother models KR830 or KR850. When it comes to 3D printing, I've included a table of suggested slicer settings for each part based on my own test slicing in Cura and printing with PLA or PLA Pro filament on an Ender 3 V2. These times and filament weights are estimates, and of course your experience may vary depending on your printer and slicer and chosen filament. I do want to call out one setting that I think is particularly important for this project though, the Z-seam placement. When the printer joins the starting and ending points of each layer, it usually leaves a tiny bit of extra material at that spot, which can cause noticeable bumps or defects depending on how they're placed around the model. Almost all filament-based projects have to deal with this in some way or another, and often it's a mostly cosmetic consideration. But in our case, because we have functional parts that need to slide smoothly against other parts, it's extra important to control where those bumps end up so they don't cause extra friction. I've had pretty good results setting mine to sharpest corner, but you could also go the extra mile and manually place your seams somewhere out of the way. The needle bed component I've included in the provided STL files holds 25 needles at either a standard 4.5mm gauge or a 6.5mm mid-gauge spacing. If you want a bed with a different number or spacing of needles, those parameters can be changed in the params.scad file. You'll then need to export the updated models from needlebed.scad, backcover.scad, and spongebar.scad in scad/parts. Obviously, 25 needles is a lot less than you'd need for most projects, but it results in a part that should fit comfortably on your 3D printer. To create a wider work area, you can print multiple needle beds, which you can then slot together in series. To assemble your needle beds, you will need to print the left and right carriage rests, 2 carriage rest clamps, 2 clamp heads, 1 or more needle beds. I recommend starting with just one and testing it out before printing any additional beds. 1 back cover per needle bed and 1 sponge bar per needle bed. You can also 3D print the bolt and nut for the clamp, but you may want to substitute a metal eye bolt and nut instead. You will also need latch hook knitting machine needles, KR830 or KR850, 1 per needle bed slot for each bed. Self-adhesive foam weather strip or something similar for the sponge bar. Machine screws. A screwdriver. And scissors or a utility knife. For each needle bed, insert a needle into each slot with the hook end towards the angled edge of the bed. Make sure the needles are sliding smoothly and sand or file any imperfections if necessary. Screw the back cover to the rear of the needle bed. Any orientation is fine, it's symmetrical. Make sure the screw heads are sunk into the well below the surface of the cover, but be careful not to over-tighten them. Cut and apply the foam strip to fit the flat underside of the sponge bar. Make a cut through the foam strip at the position of each screw hole for the screw and the spacer to pass through. Screw the sponge bar into place, taking care that the foam strip doesn't get caught between the spacer and the cover. Once in place, the sponge bar should be flush with the surface of the rest of the needle bed. And again, ensure the screw heads don't protrude where they might catch on the carriage, but avoid over-tightening them. For each carriage rest, remove the 3D printing supports, sanding any resulting rough surfaces if needed. Screw the clamp to the bottom of the carriage rest, ensuring that the surfaces are flush. Insert your clamp nut into the hexagonal cutout in the clamp and the bolt from the opposite side. Once the bolt has cleared the nut, you can insert the tip of the bolt into the clamp head and, when all the beds are connected, tighten to the table. You may want to glue or otherwise permanently attach the nut and the clamp head. I keep mine separate since they are a bit of a tight fit around my table, and it's nice to be able to disassemble them. To assemble your carriage, you'll need to print the back plate, 2 tension cams mirrored, 2 tension pointers, the yarn carrier, yarn feeder, and stripper plate. You'll also need your machine screws, nuts, and washers, some pliable jewelry wire, a screwdriver, some pliers, side cutters or nippers if you're cutting the wire, and I also recommend safety goggles if cutting the wire. For each tension cam, insert and glue a nut into the space provided. Insert the tension cam's pivot point into the appropriate hole. The nut side of the cam will be against the plate in the region of the arc-shaped cutout. Holding the cam in place, flip the assembly over so the flat side is facing you and screw the round end of a tension pointer to the underside of the cam pivot. Insert a washer between the pointer and the plate and connect the pointer, washer, plate, and tension cam with a screw. With the angled face of the yarn carrier cover facing down and the cone-shaped side of the yarn feeder facing up, screw the 2 parts together. Flip the yarn carrier assembly over and align the stripper plate pieces under the opposite edge so that the points of the stripper plate form a small gap under the yarn feeder hole. Screw into place. With the flat side of the cam plate facing up, align the yarn carrier assembly with the screw holes at the front edge of the cam plate that's closest to the hold position. Screw into place. Create a yarn guide with the jewelry wire by coiling around a small cylinder 3 times. Form one end of the coil into a small loop, or you can otherwise finish the cut edge according to your preference. Form the other end into a flat loop or coil and wrap around a screw. Secure the yarn guide with the screw in the middle hole at the back of the carriage, and then adjust into your preferred position to guide the yarn towards the yarn feeder. So machine knitting is a skilled craft that takes time and patience to learn, just like hand knitting. If you've never knit by machine before, be prepared to spend some or maybe even a lot of time practicing techniques before it starts to feel comfortable. A full introduction to machine knitting is a bit beyond the scope of this video, but there are lots of approachable lessons elsewhere online. For information that's going to be the most relevant to this style of machine, I recommend looking for techniques demonstrated on simple single bed machines such as the Bond Ultimate Sweater machine. There are a few differences between those machines and this one, but they do have a lot of the basics in common. I'm personally a big fan of Cheryl Burnett's Meet Your Bond series, which I'll link down below. So for now, I'm just going to focus on the essentials you'll need to get set up for the first time, but if you'd like to see me knit an actual project on the machine, check out my tall striped socks video. This machine uses standard gauge needles, which can knit a range of yarn from lace or fingering weights on the 4.5mm gauge bed, to sport or DK weights on the 6.5mm beds, to some lighter worsted weights on every other needle or on a 9mm gauge bed. Outside of that range, you'll be in kind of uncharted territory. I haven't tested any yarns or gauges finer than that, and I found that the heavier end of that range is definitely a bit less reliable and doesn't leave as much room to fine-tune the tension. For your first projects, look for smooth, evenly textured wool or quality acrylic yarns in fingering, sport, or DK weight. I would avoid any bulky or heavily textured art yarns, any slippery fibers, or very inelastic cotton yarns, at least until you're more comfortable with the machine. Your yarns should also be wound into a ball or cake or other format which can feed smoothly from the center. You'll need to add weights to the knitting as it comes off the machine in order to maintain the proper tension and help pull the old stitches over the new ones. If you've previously knit on other machines, you might be used to casting on a row of stitches first and then adding weights, but this machine really prefers to cast on into something that's already got some tension on it. I use a weighted hem or cast-on rag with a built-in pocket to hold a metal rod or bar, but you could also use a cast-on rag with claw weights if you already own some. For my own weighted hem, I use just a flat version of the split-ring cast-on bonnets I made for my circular sock machine, but there are many other options to get started. The key features you want to look for are that it has pre-existing loops to hang onto your needles and something to attach your weight to so that it's distributed evenly across the width of your project. You might want to experiment with different amounts of weight. You might need more than you expect, and keep in mind that different projects also might require different amounts of weight as well. If you don't have enough weight on your project, some things you might notice are dropped stitches, unintentional tucked stitches, or split stitches, or you just might end up with a loopy mess that won't knit at all. So you'll want to set up your machine on a smooth, flat work surface with a long, straight edge. I like to place a non-slip mat under the bed to help keep things secure. Make sure your work area is clear of any clutter that could catch on the yarn or block any part of the machine. Connect the needle bed segments to each other and to the carriage rests by inserting the tabs on the leftmost segment into the slots on the rightmost segment. When all the pieces have been connected, clamp the carriage rests to the table by tightening the bolts. You might need a few additional tools depending on the techniques you plan to use. I usually keep the following tools handy: a latch hook, a pick or loom tool, double-eyed needles or a transfer tool, bobby pins to hold or mark stitches, weighted and unweighted clips to hold loose yarn ends, claw or fork weights to balance out the edges, scissors or thread nippers, tapestry needles, and extra ravel cord and waste yarn. Tension can be adjusted by loosening the screws at the sharp end of the tension pointers and pivoting the tension cams to a new position. If you set the pointer more towards the top edge of the carriage, this will loosen the tension, while settings toward the side edge of the carriage will tighten the tension. Retighten the screws to set the new tension. Needles with their butts aligned all the way to the back of the bed are out of work. These needles will not be actuated by any cams, will not form stitches, and should not hold any yarn. Latches should be closed before placing needles in this position. The home position for needles exiting the carriage is the standard working position. Between the working position and the hold position is the forward working position. This is at the point where the latches have just pushed forward past the old loop on the needle. With the Mark II carriage, needles in both these positions will always knit. The forward working position can be used when returning needles to work from the hold position or any other manipulations that leave the live stitch behind the latch. Since the stitches are behind the latches in this position, it is important to ensure latches are open before knitting the next row. Otherwise, the hook will not be able to catch a new loop of yarn before the old loop is dropped, and this will result in dropped stitches. Needles with their butts aligned all the way to the front of their slots are in hold position. These needles will not be actuated and will not knit, but they can hold live stitches, which is useful for tuck stitches and short rows. To cast on, push the required number of needles into a working position, so the tips of the hooks should be at or just past the edge of the needle bed. Hang a loop from your cast-on rag onto at least every other needle and then add your weights. Set the carriage onto the carriage rest, aligning the needle bed's rails with the corresponding channels in the underside of the carriage. The stripper plate will hook under the angled front edge of the needle bed. Before knitting with your project yarn, I recommend establishing several rows of waste yarn. This can usually be reused many times, so don't worry, it doesn't really need to go to waste. Set the yarn into the carriage by feeding it through the wire coil, over the top of the carriage, and into the slot in the yarn feeder's funnel. Pass the yarn through the gap in the stripper plate and secure it with a clip. Pull a little bit of yarn out of the ball so that it will feed freely when the carriage is moved. Make sure the latches of all the working needles are open so that they can catch yarn as the carriage passes over them. Using gentle downward pressure, slide the carriage towards the needles, starting slowly to watch that the first needle catches the yarn. Continue sliding the carriage across the entire needle bed until all working needles have been cleared. Check that new stitches have been formed successfully through every loop and that every needle now holds yarn. If not, you can correct the missed stitches manually if it's just a few, or you can remove the knitting and rehang the cast-on rag to start again. If stitches are consistently not forming correctly, double check that all latches are open, enough weight has been added, and yarn is feeding through the wire coil guide and into the feeder. Between rows, pull more yarn out of the ball if necessary so that it will continue to feed freely. As you start each new row, gently tension the yarn with one hand as you slide the carriage back towards that first needle. You want to remove any excessive slack from the yarn feeder so that the loop formed around the first needle is snug. Once the first couple of stitches have formed, you can let the yarn go and let it feed freely again. Once you've established a few rows of waste yarn and the stitches are consistently knitting correctly, you can switch to project yarn and cast on using whatever technique is called for in your pattern. For ease of removal later, I always recommend separating the waste yarn from the project yarn with a single row of ravel cord. Some common causes of issues include insufficient weight, improperly closed latches, or yarn not having been properly fed into the yarn guide and yarn feeder. These can cause drop stitches, skipped or tuck stitches, or split stitches. Some other issues you may encounter include tension problems. If you're getting overall poor tension that you can't fix by adjusting the tension cams or changing to a different gauge of needle bed, it could mean that the yarn you've chosen just isn't a good fit for the machine. For example, it might be too thick or too textured to fit into the hook of the needle, or for one stitch to pull smoothly through another. On the other hand, if you had good tension that suddenly changes, it might mean that the yarn is suddenly not flowing freely out of the ball. For example, if it catches on another object, if it gets knotted, or if it gets wrapped around the yarn coil. To correct these problems, just pause and check for any of those impediments before reknitting any problem stitches if necessary. Carriage jams. Sometimes the carriage may jam due to one of its edges catching on part of the needle bed, usually where a connection between two beds is not completely flush. In this case, the jam can usually be cleared by gently lifting the leading edge of the carriage 1 to 2 millimeters and gently sliding forward. If this happens to you, Double check that your work surface is flat and smooth, that there are no unexpected objects under any part of the bed, and that your beds haven't warped or deformed. In some cases, the cause of a jam might be a needle which has hit an unexpected obstacle due to being out of position. For example, if a needle which should be out of work has slipped forward slightly. If your needles are slipping out of position frequently, it's a good sign that you may need to check your sponge bar. The sponge may need to be replaced, or the gaps for the screws may be too wide. Sometimes these needle jams may occur while the needle is underneath the carriage, in which case it's difficult to see the source of the problem. If you can't see or reach the needle to diagnose the problem, I recommend just removing the carriage altogether. Lift the carriage off the rails, tilt it forward to clear the needles, and set it aside. You can then unknit any worked stitches from the unsuccessful pass and just reset to start the row again. Regardless of the cause of the jam, it's really important to stop moving the carriage. Do not try to push through any sudden, unexpected resistance. Sometimes a needle jam can be cleared by gently wiggling the carriage back and forth for, like a centimeter or two, but attempting to force it may damage your machine. So some of the plastics used for 3D printing are more vulnerable to heat than others. When not in use, you're going to want to store your knitting machine components in dry conditions, at room temperature, and out of direct sunlight. Do not leave the parts in a hot car or near any other sources of heat. Any parts which slide, especially the cams and carriage rails, may occasionally benefit from a wax or plastic-friendly lubricant in between projects. To be honest, this is not something that I found myself reaching for a whole lot on this machine, but I do find it makes a really big difference on my circular sock machine, which is made from the same materials, so your mileage may vary. When storing the needle beds, be especially careful of the needle hooks and latches. They can be damaged if they get caught on foreign objects or otherwise treated roughly, and that'll mean they won't knit correctly. The walls between the needles may also be delicate and should also be treated with care. So that's the knitting machine. Go forth and download, and make sure to let me know if you try out any cool changes. If you've been enjoying my videos so far and you'd like to help me continue making more of them, have a peek in the description for a couple of different ways that you can help support my work. I have lots of other non-knitting related projects that I'm really looking forward to sharing soon, but don't worry, this is definitely not the last you'll hear of this one. Until then, stay curious.